Hello, everyone, and welcome to yet again another edition of Math in the Same Silly Hat. Well, there's a reason for it. I'm going to be talking about a topic today, outliers that relate to the range as well as the data sets we talked about last time. This is a bit of a rough topic. Let's get into it. All right, so we're talking about outliers today, and the first thing I need to do is define what an outlier is. So from just a simple Google search, in statistics, an outlier is a data point that differs significantly from other observations. An outlier may be due to variability in the measurement or may indicate experimental error. The latter is sometimes excluded from the dataset. An outlier can cause serious problems in statistical analysis. Bro, what? So here, the rudimentary English definition may be useful. A person or thing situated away or detached from the main body of the system. All right, I can work with that. So statistically, an outlier. Well, it looks like this little guy right here. Okay, so something that's far away from the rest of the data. Or this little guy right here. It's a data point that doesn't fit with the trend of the rest of the data. But what does an outlier look like in real life? Well, maybe that'll help us understand what an outlier is and how to identify one in mathematics. Range of the data set. Well, just a range. And here specifically, there's some sheep on a range. We're having some delicious synonym buns today. So here's a group of sheep, and they're being herded by some cattle dogs. Now you'll notice most of the sheep are here with the cattle dog, but what's over here? Some renegades. We gotta go get them and round them up, boys. So we're gonna go do that. You know what does that? The sheepdog. He's like, hey, little sheep, time to get rounded. So sheepdogs look for sheep that are away from the majority of the group. If the majority of the group is together, hey, this little guy's a little bit behind, but he's still with the majority of the group. These sheep out here, they need rounded up. Those would be our outliers in this data set of sheep. So mathematically, let's look at some examples. All right, so here we are in ALEKS. Now you'll notice this topic is not specifically about outliers, but it's going to contain an outlier that we can easily identify. You'll notice the data set, just like we talked about last time, is arranged from least to greatest in an ascending order. So if we look at our values, we have some of the 2, the 3, the 4, the 500s, and then one value in the 700s. So let's represent this graphically, shall we? All right, now here I am in Desmos Graphing Calculator. Now this is the Ohio State test version, so this is the version of Desmos you'll have available for the state test. All I've done is I've set my X and Y axis to have a range from 200 to 800. So a range of 600 here. And then I plotted my points as values along this X axis. Now you notice that most of these are all pretty closely clustered together. And then there's a great deal of space. And that sheepdog needs to herd that green point, 737, closer to the rest of the pack. Go get him! This is certainly an outlier. Let's look at one more example. In this example, we're given 7 numbers that don't seem to have an outlier. They're all in the 5 and 600s. But the question asks, what would happen if we change the smallest value to about 100 less? My speculation is because all of these numbers are in the 5 and 600s. If I gave us a value in the 400s, it would be an outlier since it would be so far away from the rest of the group. Let's represent this visually and talk about what that means. All right, so visually, it looks like all of our data is clustered very close together. Now we can zoom in just a little bit. Most of the data is in this range from 546 to 605. So this may already be an outlier. But the question asks, what happens when we change this 546 to 469? So let's make that change. My speculation was that would be an outlier as well. Let me mark up my screen a little bit. You'll notice that most of the data is right here. However, we at the start had an outlier over here. And with this change, this value is certainly an outlier since it's so far away from the majority of the data. So just by looking at numbers values, we can likely see whether or not they are an outlier. And if we just plug them into the Desmos graphing calculator, we can pretty clearly see when we do have an outlier. So hopefully this visual demonstration has helped you understand what an outlier is, a value that is far away from the rest of the pack of data. Try to think of those sheep all herded together. When one sheep is far away from the rest of the sheep, it needs herded back. It has left the pack and it is an outlier because it's lying outside of its group. I hope this explanation has been helpful. And now, even if not mathematically, you can visually or by sight recognize outliers as numbers that are far away from the rest of the group. Have a great day, everyone. Bye-bye!